In India, a total of 75 lakh hectares of land is affected every year due to floods. This water calamity not only affects crops and property, but also an average of 1600 lives are lost, and damage caused is estimated to be of 1800 crores. In these situations, the biggest questions that arise are: isn't there any technology to predict the floods beforehand? How do the early flood detection systems work? Is there any way possible to prevent the damage?
The answers. Let us explore the present solutions that are used worldwide to prevent flooding. China has accepted the concept of sponge cities. In this, the city is made up of permeable substances so that the rainwater seeps into the sand and gets collected into aquifers. They also process the flush toilet water and use it to irrigate gardens, washing, and even for drinking purposes. Another used solution is to separate rainwater from the sewer systems. The rainwater can be used directly, and it also decreases the load on wastewater treatment plants. Sometimes the geography of a place also helps in prevention. At some places, this problem is tackled by creating floodplains and overflow areas for rivers. Water can be retained and absorbed here, thereby shielding nearby towns from the effects of heavy rainfall.
All these are the non-technological solutions. But is there any way we can use modern technology to help us with the flood detection and prevention? Let's get to know. IoT, the Internet of Things, is also referred to as the technology of modern times. It's a system of interrelated computing devices, mechanical and digital machines, each with a unique identity connected through a network with the ability to transfer data without requiring human-to-human or human-to-computer interaction. Many companies have come up with an IoT model that can keep track of the conditions of the nearby reservoirs with the help of Arduino. Here is the working of the model. Firstly, the hardware unit is placed in the flood-prone areas. The Wi-Fi module acts as a transmitting unit, and the sensors associated with the system measure the corresponding parameters. Then, the accurately measured parameters are displayed through the LCD display and passed to the IoT web application. The model comprises an Arduino and some essential sensors to predict about the flood. Let's get to know these components one by one.
Arduino is an open source electronic platform that establishes a connection between the hardware and the software. They are designed in such a way that it reads the input as the water level. As the water level reaches a certain threshold, the output gets triggered and sends the alert. The warning systems must have sensors to identify flood-like situations beforehand. There are 3 different sensors which are generally used. The first of them is the ultrasonic sensor. At its core, the ultrasonic distance sensor consists of 2 ultrasonic transducers. One acts as a transmitter which converts electrical signals to 40 kHz ultrasonic sound pulses, and the receiver listens for the transmitted pulses. These sensors are used to determine the distance traveled by the pulse.
The next comes the Waterflow sensor. It consists of a plastic valve through which water can pass. A water rotor along with a Hall effect sensor is present in the sensor and measures the water flow. When water flows through the valve, it rotates the rotor. By this, the change can be observed in the speed of the motor. This change is calculated as output as a pulse signal by the Hall effect sensor. Thus, the rate of flow of water can be measured. Lastly, we come across the water level sensor. The working of the water level sensor is pretty straightforward. The series of exposed parallel conductors together act as a variable resistor, whose resistance varies according to the water level. The change in resistance corresponds to the distance from the top of the sensor to the surface of the water. This complete model together acts as a powerful aid to detect floods. They are very useful as it ensures scalability and reliability of the flood management system.
But as we know, no model is foolproof, and so this model also has some disadvantages. Like some people may not be able to access these warnings at all times, especially in case of flash floods, as it may happen too quickly for a warning to be effective. These models do not stop land from flooding. They just warn people that a flood is likely. These models work on the principle of gradient descent, in which adaptive learning algorithms are used. These algorithms do not indicate sufficient accuracy for rainfall prediction. These models are complex and expensive, whose installation and maintenance requires a high cost that the government has to bear. So, these models are difficult to install in small towns or villages.
Till now, we have dived deep into the IoT-based solutions that are available at the present times. So, is there any scope of further improvement in the future? The answer is yes. The use of modern-day technologies to develop a real-time solution in order to control the everlasting issue of floods is quite capital-intensive. Sensor networks using IoT must be installed for data collection, data processing, and dissemination of warning instructions. The main factor determining the cost is sensor site locations. Data from moisture and ultrasound sensors to check real-time moisture and water level can be used for further research.
Concluding this topic, we can say that the damage caused to land, mental health, and livelihoods of people can be minimized with the help of technologically advanced warning systems and flood control systems. There is a lot of scope for development of flood control systems in India with the help of proper funding and efficient implementation. Thank you for watching. Meet you soon with the next topic. Till then, stay tuned and please like and subscribe for more such interesting videos.